Hello students, welcome to Educate. In this video, we will discuss about first order gaseous phase reaction. That means the reactions in which there will be involvement of gases and the order of reaction will be 1. That means we will discuss about the gaseous phase first order reaction. So here let's A is a gas that give B and C. That is here. Listen firstly, partial pressure. What is partial pressure? Partial pressure is the pressure exerted by the individual gas. Suppose there is a container. Here is a container. In this container, this one is closed. There is nitrogen, hydrogen, oxygen, neon. This one. The pressure exerted by the neon, that will be called partial pressure of neon. The pressure exerted by oxygen, that will be called partial pressure of oxygen. The pressure exerted by hydrogen, that will be called partial pressure of hydrogen. And the pressure exerted by nitrogen, that will be called partial pressure of nitrogen. Total pressure will be summation of all of them. So P total, that will be equal to partial pressure of neon plus partial pressure of oxygen plus partial pressure of hydrogen plus partial pressure of nitrogen. So P total will be summation of the partial pressure of all the gases present inside that container. So partial pressure is the pressure exerted by the individual gases. That will be called partial pressure. So here partial pressure of A, B and C we will have to consider. Let's see at t equal to 0. So at t equal to 0 there will be the particles of A only. So what will be the pressure? That will be the partial pressure of A. Now at t equal to, that means at t, what will happen? If one particle of A will dissociate, there will be formation of one particle of B and one particle of C. If 5 particles of A will dissociate, then there will be formation of 5 particles of B and 5 particles of C. If X particle of A will dissociate, then there will be formation of X particle of B and the X particle of C. What will be the partial pressure of A? So initial partial pressure was Pi and its pressure has been decreased by X. So the partial pressure of A at T will be equal to Pi minus X. One particle has dissociated to give one particle of B. So X particle of A, if the partial pressure of A will dissociate through X, if the X particle, if the partial pressure of A will decrease through the value of X, then the partial pressure of B will increase by the value of X, and the partial pressure of C will also increase by X. So at T, the partial pressure of A will become Pi minus X. The partial pressure of B will become X and the partial pressure of C will also become X. But at the reacting vessels here, what the pressure is, total pressure is exerting over this container, that we can calculate. But it is very difficult to find out what's the partial pressure of nitrogen, what's the partial pressure of hydrogen, and what's the partial pressure of oxygen. So we will have to consider about P total, because when we will have to calculate the rate of reaction, the rate constant of this reaction, the rate of constant of this reaction will be equal to same as 2.303 upon T log when the reaction was taking place In the solution, that time we have taken R naught by R. That means we have taken the initial concentration of reactant and the final concentration of reactant. That means the initial concentration of reactant, that means the concentration of reactant at T equal to 0, and the final concentration of reactant means the concentration of reactant at T. When there will be gasage, the reactant and the reactants will be the gasage. So during that case, we will have to write rate constant will be equal to 2.303 upon T log partial pressure of reactant, initial partial pressure of reactant, that means this one, upon final partial pressure of reactant. Initial partial pressure of reactant upon final partial pressure of reactant. That will have to take. So initial partial pressure of reactant upon final partial pressure of reactant. That we will have to take. So initial partial pressure of reactant is Pi, and you will have to find out the final partial pressure of reactant. That is Pi minus X. But X will be how much? How to calculate? We can calculate P total will be how much and Pi was how much. That means what's the total pressure at T equal to 0 and what's the total pressure at a particular instant of time. That means we have at this container we find out, we can measure the initial partial pressure and the final initial pressure and the final pressure. The initial pressure was the partial pressure of A and final pressure is how much that we can measure. So we have to find out the final partial pressure of A. So there is X. What is the X? That we will have to calculate. So let's see on this expression. P total, that will be equal to this pressure plus this pressure plus this pressure. That means at T, total pressure will be Pi minus X plus X plus X. This X cancel out. That will equal to Pi plus X. So X will be equal to P total minus Pi. Okay. X will be equal to this much. So final partial pressure of A, final partial pressure, that will be equal to how much? Pi minus X, and X we have calculated here. So that will be equal to Pi minus P total minus Pi. That is equal to 2Pi minus P total. So that's why total pressure, that means K will be equal to here at this instant, K equal to 2.303 upon T log initial partial pressure of A, that means Pi, and final partial pressure of A is how much? Final partial pressure we have calculated 2Pi minus P total. 2Pi minus P total. That's why this is the value, this is the final answer. You may watch out here. Finally that has came 2.303 upon T log Pi upon 2Pi minus P total. Okay guys, derivation. And if you in the 12th board examination, usually the question asked directly, this question directly asked, but for main examination or for the NEET examination, you will have to know about the derivation, because the equation what will be there, that will vary from equation to equation. Okay, so now let's see how to solve this question. In the 12th board examination, question directly will ask this one. This question will directly ask. There will be this one, cut and paste. Now, so firstly, how to solve this question? But if you are considering about the IIT main, then you should know how to derive the equation, how I have derived that equation. Okay, so this is here. Let's see about the question. What the question is? Question is, here the reaction is N2O5. That means that is giving nitrogen pentoxide that is dissociating into nitrogen dioxide and oxygen. Nitrogen pentoxide that is dissociated into nitrogen tetroxide and oxygen. And at T equal to 0, the total pressure is 0.5. So that will be the partial pressure of N2O5 only. And at T equal to 100 seconds, the total pressure is 0.512. It is here, and you will have to find out the rate constant, that means K. Okay guys, this one is question very easy. At T equal to 0, the partial pressure of A has been given, because total pressure will be equal to the partial pressure of nitrogen pentoxide. And at T equal to 100 seconds, the total pressure has been given 0.512 atm. So 0.512 atm is the pressure of N2O5 plus N2O4 plus O2. This one. So let's see here directly on the questions. This is the equation here. At T equal to 0, the total pressure will be 0.58. The total pressure is the partial pressure of N2O5, that's why 0.5 atm, and partial pressure of N2O4 will be 0 and oxygen will be 0, because initially there will be the particle of N2O5 only. There will be no particles of N2O4 or O2. At T, here stoichiometric coefficient is 2, here 2, here 2. So that means 2 moles of N2O5 will dissociate to give 2 moles of N2O4 and 1 mole of O2. If there will be 10 particles of N2O5, then 10 particles of N2O4 will form and 5 particles of oxygen will form. So if its pressure will decrease by suppose 2 atm, then the partial pressure of N2O4 will increase by 2 atm and the partial pressure of oxygen will increase by 1 atm. That is based on the stoichiometric coefficient. So if at T equal to 100 seconds, it has assumed that the partial pressure of N2O5 has decreased by 2x. The partial pressure of N2O5 has decreased by 2x. So at T equal to 100 seconds, the partial pressure of N2O5 will become 0.5 minus 2x. And its partial N2O5, the partial pressure has decreased by 2x. So the partial pressure of N2O4 will increase by 2x. So that means at T equal to 100 seconds, the partial pressure of N2O4 will be 0 plus 2x. That means 2x. Same, the partial pressure of oxygen, because here if the partial pressure of N2O4 will decrease by 2x, then the partial pressure of oxygen will increase by x. So at T equal to 100 seconds, the partial pressure of oxygen will become x atm. Total pressure will be equal to summation of all of them. So summation of all of them, this one, so 0.5 minus 2x plus 2x plus x. So 2x and 2x that will get cancelled out. So 0.5 plus x, that is here. So at T equal to 100 seconds, the total pressure will be 0.5 atm plus x. And at T equal to 100 seconds, the total pressure has been given 0.512. So 0.512 will be equal to 0.5 plus x. They are not given. So listen here. So that means 0.512 will be equal to 0.5 plus 2x. 0.512 atm will be equal to 0.5 atm plus 2x. So 2x you can calculate 0.512 atm minus 0.5 atm. So the value of x you can calculate very easily here. So that will be equal to 0.012 atm. 2x is that. So x will be equal to 0.006 atm. Okay, let's proceed. So partial pressure this one 0.5 and that was x was that much. So 2x will be how much? 2 into that much. So partial pressure of N2O5 will be how much? Initial partial pressure was 0.5 and final partial pressure was 0.512. Okay, here you may calculate initial partial pressure is 0.5. Initial partial pressure 0.5. Now final P total, that will be equal to 0.5 minus 2x plus 2x plus x. That equal to 0.512. So x will equal to 0.012. So final partial pressure will be 0.5 minus 2x. That means 0.585 minus 0.012 into 2. That is 0.5 minus 0.024. .476. So final partial pressure will be 0.476. Now you will have to find out rate constant. Is it rate constant? So rate constant will be equal to 2.303 upon T is here 100 log initial partial pressure 0.5 atm, that upon final partial pressure is 0.476 atm. Now calculate this one, you will find out the rate constant. Okay guys, very easy to solve this question. Suppose here how to find out log. So suppose log 15 you have to find out. So that will be equal to log 1.5 into 10. There should be only one digit left to the decimal and there must be one digit left to the decimal. So that will be equal to log 1.5 plus log 10. Log 10 will be 1. So that will equal to 1 plus log 1.5. How to find log 1.5? That can be written as 1.50. So in the log table, in this line, this vertical line, there will be 1, 2, 3, 4, 5, 6 like that. So there will be 15 here and here 0, 1, 2, 3, 4, 2, 9 here. So 15 and 0 here. So at this, what will be the value? Put the decimal, write that. Okay. So like that, how to find out the log table. That was, we have discussed how to we get the log table. Then after, so that means after the calculation, 0.476 we have calculated, 0.5 upon 0.476. That is, and after calculating this one, that value has came. Now let's see half-life period. Very important, half-life period. What is half-life period? As the name indicates, half-life means life of half portion. So half-life period can be defined as the time period during which the concentration of reactant will become half of the initial concentration of reactant. half-life period. So half-life period is the time period during which the concentration of reactant will become equal to half of the initial concentration of reactant. Half-life period is the time period during which the concentration of reactant will become half of the initial concentration of reactant. Okay, so now let's see for zero order reaction, for a first order reaction, and what will be there. So for zero order reaction, you have already studied about the half-life period for zero order reaction. Yeah, first order reaction. Okay, so for the zero order reaction, you have studied K equal to R naught minus R by T. That have you have studied. At T half, R will be, concentration of reactant will be half of the initial concentration of reactant. So rate constant will be equal to R naught minus R naught by 2, that whole upon T. So here 2 R naught minus R by T 2, so that will equal to R naught by 2T, 2T half. So you can write that T half for zero order reaction, T half will be equal to R naught by 2K. Watch about this point, R naught by 2K, that final expression has came. Okay, now watch out. For zero order reaction, half-life period is directly proportional to initial concentration of reactant. That means if you will take greater amount of reactant, then that half of the reactant will consume fastly. That is meaning T half is directly proportional to initial concentration of reactant. That means the half-life period in case of zero order reaction, half-life period is directly proportional to initial concentration of reactant. Means if you will take more amount of reactant, then half of the reactant will consume fastly. Okay, T half will be that, means that much T half, that means that will take more time. If more be the concentration of reactant, more time it will take to consume. Okay, now let's see about the first order reaction. So for the first order reaction, you have studied for first order reaction. So for first order reaction, you have studied K equal to 2.303 upon T log R naught by R. And at half-life period, T half, the concentration of reactant will be equal to half of the initial concentration of reactant. So put the value here, R naught by R by R naught by 2. So K equal to main division line is this one. That means R naught divided by R naught by 2. That means that will be equal to R naught into 2 by R naught. So that's why here, and you can also write T half will be equal to 2.303 upon K log here R naught into 2 by R naught. R naught cancel out, so that will be log 2. That means T half will be equal to 2.303 upon K. T half will be equal to 2.303 upon K log 2. And log 2 is 0.301. So log 2 will be 0.301. That's value everyone have in the mind. So T half will be equal to here when you will multiply 2.303 with 0.301, that will be 0.693. So T half will be equal to watch out, in case of radioactive disintegration, same formula you got. So here the radioactive disintegration is an example of first order reaction. The radioactive disintegration is an example of first order reaction. So this one here, and watch out, the half-life period is independent of the initial concentration of reactant. Here in zero order reaction, more be the initial amount of reactant. In case of zero order reaction, more be the initial concentration of reactant, more be the time period. But here in case of first order reaction, the initial concentration of reactant will be less or more. The half-life period will not depend on that. That is, the half-life period is independent of the initial concentration of reactant in case of first order reaction. Okay guys, this one. This derivation which we have discussed, that is here, same. Now watch out this question. This question, that has been written in the bold line. For zero order reaction, T half is directly proportional to concentration of reactant, and for the first order reaction, T half is independent of initial concentration of reactant. That is very easy. We have already discussed. Now let's see on this question. Here in the questions that is given first order reaction it is, and K is that much. In the NEET examination, that will not given what is the order of reaction. In the NEET examination, question will directly for the first order for a reaction, the rate constant is this one. What is half-life of the reaction? Okay. Here in this one given here, and in 12th board examination, this question will give you directly. But if you are considering about the NEET examination or the CUET examination, then keep in the mind that if the unit of rate constant is time inverse, that is second inverse or minute inverse or R inverse, then half rate constant is this one, then you will have to predict by yourself that the order of reaction is 1. That means this reaction is a first order reaction. So half-life period it is asking. So very simple here, half-life period you know already. For the first order reaction, half-life period is equal to 0.693 upon K. Okay. So half-life period you have to find out. So 0.693 upon K is this much. Second inverse here, it will go in the numerator, that becomes second. So what will be here? What's the calculation here? calculation, after calculating this one, it will get 1.26 into the 10 power 13. And here, this second inverse, when go in the numerator, that becomes second. So the half-life period will have the unit of second. Okay. Now, this question frequently asks in the 12th board examination, and based on that, not in case of IIT main, the question don't ask directly from here. That means here not to this one, but the questions related to this one. If you will have the concepts of how to solve this question, then you could solve the question asked in IIT main related to this topic very comfortably. So firstly, let's see how to solve this question. And for the two who are considering about the IIT main and his dropper, that guys will have to only listen, but will not have to practice a lots. No need to practice a lots, because question will comes in different format. But the student who is in 12th board examination, that will have to listen very carefully and will have to practice this question also. Let's see here. Question is, you have to show that the completion 99.9% in reaction is complete, and you will have to prove that it will be 10 times of the half-life period. So let's see here how to solve. What's the meaning here? 99.9% has been consumed. So concentration of reactant will become equal to initial concentration of reactant minus 99.9% of 99.9% of the initial concentration of reactant. So that will be equal to this is initial, that means the concentration of reactant will be equal to 10 to the power minus 3 R naught. So you know already T here 99.9%, that will be equal to 2.303 upon K log R naught by R. This the formula you already know for the first order reaction. The time period required for the 99.9% completion of the reaction will be equal to 2.303 upon K log R naught by R, and R I have calculated 10 raised power minus 3 R naught. So that will be R naught will cancel out, 10 power minus 3 will go in the numerator, that will become 10 raised power 3. Log A to the power x equal to x log A, and log 10 is equal to 1. So here log 10 to the power minus 3 can be written as 10 to the power minus 3, 10 log 10 to the power minus 3 can be written as minus here, oh sorry, plus 3 here. So 10 power 3 can be written as 3. So that will equal to 2.303 into 3, and log 10 is 1. So same here, that will equal to so that will be equal to simply this one. And we know T half, T 99.9%. And T half, that equal to 0.693 upon K. You have to compare T 99.9 with T half. That means T 99.9% upon T half. That will be equal to T 99.9%, this one. And then after you will realize that T after dividing this one, K will cancel out 2.303 into 3. That will be nearly about here 3 3 is 9, 0 3 3 is 9 and 3 2 is 6. So that will be nearly equal to 10. So T 99.9% will be equal to 10 per times of T half. That is okay, guys. Very easy to solve this question, but this question asked very frequently in 12th board examination. And if you will have the idea how to find out at a particular concentration, that means related to these questions you will have to solve if in IIT main examination also, and in NEET examination very frequently asked question, and in CUET level of question will be not so much tough, that will not in so much twisted form, but if you will solve this question then you will also get the concept how to solve the questions related to this topic. Okay, that was about the half-life period. Let's see. Watch out, log this question 3.5 and 3.6 about the pseudo first order reaction. There is this one here we have already discussed. So if we will plot this one, watch out, then very easily differential rate law question is what? dr by dt equal to minus ka, and integrated rate law is this one. Very easy to here understood this one. We have already discussed about this table. Let's solve this question. And about the pseudo first order reaction we will discuss later on. But firstly, watch out how to solve this question. Question number 3.5. Read the question carefully. So listen here, in the questions it has been given that the reaction is a first order reaction and its rate constant has been given. You will have to find out the time period during which the concentration of reactant will changes from 5 gram to 3 gram. That means the rate constant of the reactant has been for the reaction has been given. The initial concentration has been of the reactant has been given and the final concentration. So, and for this one, what will be the time period that you will have to find out. So you already know here this question how much is it? For first order reaction, K equal to 2.303 upon T log R naught by R. So T will be equal to 2.303 upon K is how much? 1.15 into 10 raised power minus 3. Log R naught is 5 gram. So 5 gram here upon 3 gram. The only calculation left which you can do very easily. Second question is time required to decompose SO2Cl2 to half of its inner amount is this much. If the decomposition of first order reaction, calculate the rate constant. Here half-life period has been given. For SO2Cl2, for the reaction, that means our reactant is SO2Cl2, and in 60 minutes, the half-life period is 60 minutes. What is its rate constant? That you have to calculate. Where is here? This one also. So you know already K equal to 2.30. T half is equal to 0.693 upon K. So that will equal to 0.693 upon K has been given how much? No, T half is given. So K you can find out. So here 60 minutes it is upon K. So K will be equal to 0.693 upon 60. That will be the answer. Very easy. Then after this, temperature dependence of the rate of a reaction. What usually? On increasing the rate of temperature, the rate of reaction increases. Generally, for general reaction, or generally, on increasing the temperature, the rate of reaction increases. And for every 10 degrees Celsius rise in temperature, for every 10 degrees Celsius rise in temperature, the rate of reaction becomes double. For every 10 degrees Celsius rise in temperature, the rate of reaction becomes double. Okay, and in the next class we will discuss about the reason for this, why on increasing the temperature the rate of reaction increases, and why for every 10 degrees Celsius rise in temperature the rate of reaction becomes twice. We will discuss in the next class. In this video we will discuss till here only. It's all for this class. Thank you, Team Educate.